Hi everybody. In this video, we're going to look at how we can model real-life situations using formulae. We'll work through 3 questions, and then we'll try an exam-style question. And if you want to work along with me, you can download this PDF from my website. I'll leave a link in the description below. So for example 1, we've been given this formula that's used to convert degrees Fahrenheit into Celsius. We've been asked to work out the temperature in degrees Celsius that is equivalent to 150 degrees Fahrenheit. So we're going to substitute this 150 degrees Fahrenheit in place of F, and then we can evaluate the right-hand side of this formula. So C will equal 5/9, 5/9, multiplied by F, which we're told is 150, minus 32. And I'm going to show you how we can do this on a calculator. So we'll begin by entering that 5/9 as a fraction. So we've got 5/9, and then we can multiply that. We'll put it in brackets, 150 minus 32. And we can execute that, and we get 590/9. We can convert that to a decimal. We press format. We want decimal, and we get 65.5 recurring. So I'll round that to 1 decimal place, and we get approximately 65.6 degrees Celsius to 1 decimal place. Okay. Now for part B, make F the subject of a formula. So you can see that currently the degree Celsius is the subject because C is equal to all of this. What we need to do is make F is equal to. So we need to move all the other terms to the left-hand side. So if we write C is 5 lots of F minus 32, and then I'm going to write this division of 9 as the entire numerator of a 9. So now I can multiply both sides by the 9, and we get 9c. This division and multiplication will cancel, and we'll get 5 lots of F minus 32. Now we can move this 5 to the left-hand side, and because it's a multiplication of 5, we'll divide both sides by 5. And again, the multiplication and division will cancel. So we've got 9c over 5 will equal F minus 32. Now finally, we can move this negative 32 over to the other side by adding it to both. The negative 32 plus the 32 will make 0, then these will cancel. So we'll get 9c over 5 plus 32 will make F the subject. And then for part C, use your rearrange formula to find what temperature in degrees F is equivalent to 160 degrees Celsius. So now we're going to substitute this value in place of C. So F will equal 9 times C, which is 160, over 5 plus the 32. And again, I'm going to work this out on a calculator. I'll begin by entering the fraction. So we've got 9, and then brackets 160, over the 5, plus that 32. We'll execute that, and we get 320 degrees Fahrenheit. So F is equal to 320 degrees Fahrenheit. Okay? So the key idea here is that by rearranging this formulae, we can model the different degrees Celsius and the degrees Fahrenheit. Let's try example 2. So in example 2, we're told you are installing a new circular patio the amount of paving material needed is determined by the area of a circle, and the formula for the area of a circle is given as A equals pi r squared. For part A, we need to rearrange the formula to make R the subject. You can see that A is currently the subject. And then for part B, we need to work out the radius when the area is 150. So if we begin with the area is pi r squared, to make the radius the subject, we need to move pi and the square term to the other side. So the first thing we'll do is we'll divide both sides by the pi. And then this multiplication and division will cancel, and we'll do it to both sides. So we get the area over pi will equal the radius squared. And now we need to cancel out this square term. So we take the square root of both sides. And then the square and the square root will cancel. So we've got the square root of the area over pi will give us the radius. And that's part A. For part B, work out the radius when the area is 150. So now we're substituting this 150 into our rearranged formula. So the radius will be the square root of the area 150 over pi. And we can do this on our calculators. We want the square root using the fraction button of 150 over pi. And we get approximately 6.91 to 2 decimal places. And this is in centimeters. Okay? Let's try example 3. So do you want to read through question 3 yourself and try and rearrange this formula to make I the subject? And when you've made I the subject, can you calculate the new value of I given these values for P, R, and K? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So if we know that P is I squared R minus K, and we want to make I the subject, we need to move the negative K, the multiplication of R, and this square term over to the left-hand side. Then we'll have I on its own. So the first thing we'll do, we'll add K to both sides. And then these will cancel. And we've got P plus K will equal I squared R. And what do you think we need to do next? So now we need to divide both sides by the R. And these two will cancel. So we'll have P plus K over R will equal I squared. Now, how do you think we cancel out this square term? So we take the square root of both sides. And then these two will cancel, the square and the square root. So what we have is the square root of P plus K over R will equal I. How did you get on with that? For part B, given that P is 250, R is 12, and K is 10, work out the value of a current I. So we need to substitute these three values into our new formula. So we'll take the square root of P, which is 250, plus K, which is 10, over R, which is 12. And this will be I. We can simplify our numerator. So we've got 260 over 12. And then on our calculators, we want the square root of 260 divided by 12. Convert that to a decimal. And to 2 decimal places, we get 4.65. So I is 4.65, and we're told the unit is amperes A. and that's to 2 decimal places. Okay? Let's try the exam style question. So do you want to read through this question yourself? Try and work out parts A, B, and C. You can pause the video, and when you come back, you can compare your working with mine. Okay, so welcome back if you had a go. So we need to find the volume when the radius is 6. So we'll substitute the 6 into this radius. So the volume will be 4/3 times pi times 6 cubed. And I'm going to write this 6 cubed in brackets. On our calculators, we'll have a fraction of 4/3 multiplied by pi. And then in brackets, we'll have the 6 to the power of 3. And we get 288 pi centimeters cubed, or as a decimal, approximately 904.8 to 1 decimal place. And then for part B, make R the subject of a formula. So with V is equal to 4 pi R cubed over 3, and I'm going to write this numerator all over 3. Then we can multiply both sides by the 3. These two will cancel. So we've got 3V will equal 4 pi R cubed. And now we can divide both sides by the 4 pi. And then these multiplications will cancel with the divisions. So 3V over 4 pi will equal R cubed. And now we can take the cube root of both sides. These will cancel. So we're left with the radius will be the cube root of 3V over 4 pi. And then finally for part C, find the radius of a sphere with volume 2,500 meters cubed. So if we substitute this volume in place of V, then we'll get the radius will be the cube root of 3 times that 2,500 over 4 pi. We can simplify our numerator, so we get 7,500 over 4 pi. And I'll work this out on my calculators. We want the cube root 7,500 over 4 times pi. And we get approximately 8.42 meters. So R, 8.42 meters to 2 decimal places. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.